Could it be that our sun is in a binary orbit, creating a 24,000-year cycle that affects the rise and fall of civilization? Many ancient cultures seemed to think so, and now some modern-day scientists agree. If true, there should be evidence of advanced civilizations older than the 5,000 or 6,000 years we find in most of today's textbooks. One of the most obvious astronomical cycles is the occurrence of the spring and fall equinoxes, the 2 days of the year where day and night are exactly equal in length. Ancient calendars were set by these consistent markers, which are still used today to calibrate universal time. And ancient star watchers faithfully observed the celestial movements and patterns in the sky. A key observation was that certain constellations follow the same path in the sky as the sun. Each year, on the day of the equinox, when they made their observations, ancient astronomers realized that over time the constellations were not in the exact place in the sky that they had been the year before. The stars seemed to be moving backwards across the sky, a movement known as the precession of the equinox. When he wrote his paper explaining the solar system, Copernicus observed 3 motions of the Earth. The first motion is the Earth's daily spin on its axis. The second motion is the Earth's annual trek around the sun. But he needed a third motion to explain precession. He used the term wobble or libration, assuming that only a wobbling Earth could cause us to see a different part of the constellations each year. Over 100 years later, Sir Isaac Newton applied his theories of gravity to the idea of a wobbling Earth. He determined that the sun and moon were the only things big enough and near enough to cause the wobble. This explanation of precession is known as the lunisolar theory. Another factor that might contribute to the wobble is the shape of the Earth. This is the predominant theory among astronomers today. But in 1749, French astronomer Jean Le Rond d'Alembert found that Newton's lunisolar equations did not quite work, so he added variables for torque and inertia. Still today, lunisolar precession formulas continue to be adjusted, and some say they don't reflect physical reality. The seasons are caused by the tilted Earth revolving around the sun. Any change in the tilt of the Earth, whether due to a massive meteor impact or the subtle wobble of lunisolar theory, would result in a change of seasons, even though our calendar would stay the same. Lunisolar precession theorists reconcile the regularity of our seasons by requiring the equinox to occur before the Earth completes its full 360-degree orbit around the sun. But this solution contradicts lunar equations and observed eclipse cycles. Each answer merely creates a new question. Could there be an easier explanation of precession? Ancient scholars who observed precession of the equinox provided a simpler explanation than a wobbling Earth. They said that our sun curves through space, moving in a great orbit of its own, pulling the Earth and other planets along with it. If the Earth did move along with the sun on a curved path through space, we might see the same precession of the equinox through the zodiac and changing of the pole stars that the lunisolar wobble theory now attempts to explain. But it would not be caused by the Earth's wobbling independent of the sun. It would be caused by the whole solar system curving through space. Another reference frame. A partner star to our own sun? Some say the binary model confirms all of our celestial observations without the need for excessive torque or epicycle type explanations. While the concept of a second sun challenges our present understanding of the solar system, it is hardly a new idea. Some of the earliest astronomical records refer to the existence of dual suns. In fact, Mithraic beliefs were based on this concept. As we look deeper into the universe and expand our knowledge of its motion, we've come to realize that single suns are more the exception than the rule. With so many binaries in the heavens, why wouldn't our sun have a partner? Then again, if it did, wouldn't we be able to see it by now with our high-tech observatories or the Hubble Space Telescope? While there might not be a visible companion, it doesn't mean one's not there. Some stars can't be seen at all, such as black holes or old neutron stars, and others, like brown dwarfs, are barely detectable. Also, the long orbit period of 24,000 years will make the connection of our sun to a binary partner extremely difficult to detect. One sign we'd expect to see would be the changes in the sun's rate of movement. In a binary system, orbital speed is not constant, and theorists say it would cause changes in the precession rate. If the current rate of speed were constant, a complete binary cycle would take almost 26,000 years. The scientists have confirmed that the rate of precession is increasing. In a binary system, this would mean that two stars are moving closer together, and the cycle would take much less than 26,000 years. The cycle of a binary system might also be observed in the geological record. Mathematician Milutin Milankovitch noticed the Earth has had global warming and cooling cycles that roughly correlate to the length of the Great Year. Just as the binary model answers questions of the past, it could also be applied to solve scientific questions of the present. For example, at the edge of our solar system is a field of asteroids known as the Kuiper Belt. In 2001, a team of scientists from the University of Michigan made a startling discovery. The asteroids appear to end very abruptly. A sheer edge like this would be expected in a binary system. Also, a large number of long-cycle comets in our solar system come from a very small part of the sky. Although some astronomers like John Matisse and Daniel Whitmire think it may result from the gravitational pull of an unconfirmed 10th planet, our sun's binary could also have this effect. Another enigma. All celestial bodies have angular momentum, a force that corresponds to their mass and motion. Yet in our solar system, angular momentum is unevenly distributed. The sun has 99.9% of the total mass, but only 1% of the total angular momentum. If we acknowledge that our sun is curving through space in a 24,000-year binary orbit, we find the sun's angular momentum was there all the time, but primarily in its orbital motion, not just in its spin. Although the possibility of a binary star agrees with many observed facts, it does raise questions. The most common objection is, if we were in a binary system, we would know it by now. But we may be looking for something that is very far away and very hard to see. New discoveries in astronomy and archaeology are adding more and more to our understanding of the true depth of our own history. If we continue these pursuits, perhaps we will prove the link between binary motion, precession, and man's place in the Great Year. History reveals that ancient cultures around the globe were aware of a great cycle that connected the movements of the heavens and life on Earth. The Great Year tracked not only time, but perhaps, we will find, the very rise and fall of civilization itself.
To everything turn. There is a season, turn.